Hello students, so let's start the new reaction. Its name is Aldol Condensation reaction. This acetaldehyde, if reacts with any base, like you have given a sodium hydroxide, potassium hydroxide, barium hydroxide, calcium hydroxide, okay, and so all. So if this aldehyde reacts with this base, it gives a beta-hydroxy butyl aldehyde that is known as a aldol product. So what we have said here, we have beta-hydroxy butyl aldehyde. This is what? This is beta-hydroxy butyl aldehyde. Now this product which we have made by the use of this base, this is called as an aldol product. What is this? This is considered as an aldol product. But we have asked about the aldol condensation. So if we say what is aldol condensation, that means you need a heat there to eliminate a water molecule from this beta-hydroxy butyl aldehyde. So after having a heat, we can remove a water molecule from this. Okay, so then after it forms as a new product, and that product is nothing but your aldol condensation product. Now what should be the basic requirement for this mechanism? Yes, the required alpha H is minimum 1. Okay, so you can say you need an alpha hydrogen for this reaction, and this is the basic part of this reaction. So let's start the mechanism of this reaction. So what is the mechanism of this reaction? It's really easy. If an alpha hydrogen is there, like we have acid aldehyde, this is the acid aldehyde we have. If this acid aldehyde reacts with any base, so this acid aldehyde, we have 3 alpha hydrogens. This acetaldehyde has 3 alpha hydrogens, and when you can see, like we have written a hydrogen atoms here, you can write it like this as well, CH2 and a hydrogen on this carbon. Okay, so when the base is given with this alpha hydrogen, it combines and removes water and forms as an acid base reaction. So a new product is formed in this reaction, that is through the acid base reaction, and water is being eliminated. So this is called as another name a neutralization reaction, and you may have a salt here. Like if you have used a potassium hydroxide, you can form a potassium salt here. Now what happens? So just check it out. So very next step, if you see an negative charge species, it attacks on a same molecule, like we have used acetaldehyde here. So this anionic species which we have made here by the use of acid base reaction, then it combines with, or it attacks with, this acetaldehyde, and this acetaldehyde is nothing but it occurs a nucleophilic addition reaction here. So if you see a nucleophilic addition reaction, what happens there? A pi bond is being shifted like this, and this anionic species will attack on this carbon atom which has a dal positive sign on it, and oxygen is dal negative sign. And after the attack of this nucleophile, that means an anion which we have formed is nothing but it is considered in this reaction as a nucleophilic part. So nucleophile attacks on this aldehyde group, and then after we have a new product. So we are seeing a mechanism, and this mechanism says that a new product is being formed as this anionic species once again. And now what we will do, a hydrolysis is being done now, and after the hydrolysis, like if we have a hydrolysis here, this on a hydrolysis, on this hydrolysis we may get a new product, that is an alcohol. So this alcohol is being obtained through this reaction. Okay, now this is an aldehyde, and what we get, this is your aldol product. As we have written, this is our aldol product, and this is what we get. We get beta-hydroxy butyraldehyde. And how will we say this is beta-hydroxy group? Now see this aldehyde, and just near a carbon which is directly attached with this aldehyde group is an alpha carbon, and OH group is present on the beta carbon. So let's say this is alpha and the next one is beta carbon, and OH group is being attached on this beta carbon, so it is called as a beta hydroxy, and 4 carbon, so that is why butyraldehyde. Okay, so we have now aldol product. So finally we have got the aldol product in this mechanism. Now let's see what happens in the very next step. As we know, a water molecule is being eliminated because a heat is being given in this reaction. So when you heat this molecule, when you heat this aldol product, hydrogen on alpha position and OH on the beta position is being eliminated. So at the end we get the final product, and the product looks like this, as we have obtained in the reaction above. This is aldol condensation we have. So if you have liked this video, please share with everyone, comment and subscribe this channel Chem Reactions. Thank you very much.